All right, welcome back from break. We are going to do some math today. So you should have in front of you the notes for section 11.2, and then you should also have your vocabulary out. We're going to have some time for vocabulary. You do have homework tonight. It's out of the book. It is on Moodle. You will have time in class to work on it, so you should be able to get it done in class. Okay, so let's start. Take out your vocab, and we're gonna fill out on the very back page. You have a section for the formulas from section 11.1. Section 11.1 we actually did a while ago, so I'm just gonna give you the formulas as a quick refresher. So if you have some regular polygon, then the sum of the interior angles in a regular polygon is 180 times n minus 2. So n is the number of sides. Each interior angle has the following measure. It's just 180 times n minus 2 divided by the number of sides. All right, then the exterior angles, the sum every time of the exterior angles in a polygon is 360. And then if you wanted the measure of each exterior angle in a regular polygon, then you would just take 360 and divide it by the number of sides. Okay, so fill those in on the back of your vocab. You might reference those in this chapter in your homework. Okay. Now flip to the notes, keep your vocabulary out. So first example, we should remember how to do this from last chapter. We would need to find the exact area of the equilateral triangle given here. The side length is 12 in your equilateral triangle. So to find the area, we're going to need to figure out what the height is. You had one just like this on your test. So we should know, because this is equilateral, this angle here is 60. And then also this altitude here bisects that angle up there, which makes this 30 degrees. So this is a 30, 60, 90 triangle. And let me just refresh your memory on a 30, 60, 90 triangle. So let's say, I'm going to make this a little bit bigger over here. Here's your 90-degree angle. Let's say here's your 60-degree angle on 30. Your hypotenuse is always double the shortest side, and then the middle side, so sorry. And then the middle side is just the shortest side times root 3. Okay, so using that knowledge, we should know that if this triangle here, this side here is 12, which is the hypotenuse. That means this side here is 6, which means that the height is 6 root 3. So if you need to find the area of the triangle, then you'd say area is 1/2 base, and the whole base here is 12. 1/2 base times height, which is 6 root 3. And so you'd simplify 1/2 here times 12 is 6, times 6 is 36 root 3. And that's going to be in inches squared. Okay, so let's do example 2, similar problem. We're going to find the exact area of the equilateral triangle with a side length s. So they all have some unknown length. We're going to do the same thing. We're going to try to figure out what the length is of the altitude, or the height of the triangle. So using our special right triangles, again, this is our 60-degree angle, here's 30. And if we know this side here is s, then that means that this side here is s over 2, which means that our height, I'm going to do this in blue so that we can see, is s over 2 times root 3, or x times root 3. So that means the area of the triangle is 1/2 base, which is this whole thing here, which is s, times the height, which is s over 2 root 3. So if you multiply across, this is really s over 1. Area would be s squared over 4 times root 3. And that is actually a vocabulary term. So if you want to get out your vocabulary, you can write this down. The area of an equilateral triangle every time is the following: 1/4 times root 3 times the side squared. So you can stop the video and you guys can write it down if you want. I'm going to just keep going here. Here's some more vocabulary. I'm not going to go through each of these, but again, you can stop the video and you guys can write this down. I'm going to scroll through. So this whole chapter is on area of polygons, and so we need to sort of make sure we know all of this vocabulary in order to answer the questions that will be asked. So the center of the polygon is just right here. And you can just sketch that picture once, and then all of these below it, 2 through, I forget how many there are here, use the same picture. So you can just say see above for the rest of these down here. So you're going to use the same picture. So the radius of a polygon would be GA, the segment GA. The apothem of the polygon, this is a new word, is the distance from the center to any side of the polygon. So in this problem, GH is the apothem. Okay, so I'm scrolling through this, but hopefully you guys can stop the video wherever you would like so you can write these down. The central angle of a regular polygon, that's important. It's just the angle AGB in this picture would be your central angle. So this one right here. Okay, one more problem and then you guys will start working on your homework. So here we have a hexagon and the sides are all 6, so it's a regular hexagon. And your task is to find the area. So there's more than one way to do this. One thing you can think about is cutting this hexagon in 2. And it creates 2 isosceles trapezoids. And if you remember the formula for area of a trapezoid, you could use that. But I don't think a lot of us remember that. So actually, I'm going to cut this up into triangles because we all remember the formula for a triangle, area of a triangle. So I have 6 of these triangles here, and they're all the same. They're all equilateral triangles because this is a regular hexagon. So if I can figure out the area of one of these triangles, I can figure out the area of the whole hexagon. So let's try to figure out the area of a triangle here. So I'm going to figure out the height, and I have the base, which is 6. So again, what you want to try to think about here is how you can figure out the height of this triangle. So one thing you need to know is that inside, here's your center of your polygon. You have these angles surrounding the center, right? All these angles in here. And if you added them all up, they should add to 360, the interior angles here. And we know we have 6 of them, and they should each measure the same amount because this is a regular hexagon. So each of these in here are 60 degrees. If you divide 360 by 6, you'd get 60. All right, which means that this angle here is 30 and that this one must here be 60, just by using triangle sum theorem. Maybe if you didn't catch that, it's because this altitude here bisects this angle here, which is 60. This whole thing here is 60, but we cut it in half. Okay, so what I have now is I know that this little piece here, I'm going to resketch this little triangle here. I know this is 30, I know this is 60. I know this length here is 3 because it's half, which means this is 6. And then the height you know to be 3 root 3. Okay, so the area of a triangle is 1/2 times the base, which is 6. This base is what I'm referring to. times the height, which is 3 root 3, which we just found. That's the area of one of these triangles. That's this, right here in blue. We have 6 of those, so we're going to multiply this whole thing by 6 to get the area of the whole hexagon. Which, if you do some simple mental math here, you would know that this 1/2 times the 6 is 3, times 3 is 9, times 6 is 54, so 54 root 3. Okay, so you should stop now. We're going to finish the rest of these notes tomorrow. I will be here tomorrow and work on your homework. So I'm going to I have the slides for your homework in this notebook file, so I'm going to flip through the slides so that way you guys can stop the video and do the homework in class. Or if you have a phone, you can do it on your phone. Okay? Whoops, let me delete that. Sorry. Okay. So I'm going to go back, and here's the first section. Here's the second section. Third. Fourth. All right, and here's the answers so you guys can check your work if you get finished. And one more time, here are the problems that you are to do tonight. I'm going to check it tomorrow just to make sure that you guys worked in class. All right, so I hope you have a good day back. I will see you tomorrow.